I'm still downloading.
Sarah had a question. So partly, Sarah, so you know that the
I could give you a USB key if this is
on the agenda,
going to be better.
we can open up this.
And is it any of those?
Why don't you put it on a USB key while he's playing with you?
Is it that one?
Yep,
Attached, so it's, no, that's Brian's.
it's correct.
Give me a damn key.
You guys are on. You're all good to go?
Fun.
Rearranging the seats on the Titanic. Yeah, no, I can't find it. Or you could resend it. I mean, if you just resend it, then
30 seconds or less from.
30
I've seen you on a
seconds.
PDF, right?
yes.
Just not it.
We have to score your distance.
Alrighty then.
And it contains the latest generation Microsoft virus to steal all your secrets.
Lucky I don't run any Microsoft operating system.
And it's a USB 1 key, so it's really fast.
No name, it says.
That's ominous, isn't it?
All right.
That's the right one.
All right.
That's
We're actually gonna steal it one more time. We can start. You can start talking note weather if you wanna.
okay. Okay, thank you for coming to token binding. If you expected to be on a different plane, please deplane now. We have our note well, please note it well, and blue sheets, which all of you will sign. I'll start distributing them from the front.
We need somebody to volunteer to take notes and a jabber scribe if possible. Somebody, let's auction off the easy job first and do jabber scribe. Yeah, somebody was smart enough to take the easy job. Thank you, Wendy. Now the hard job of taking notes. We're not starting until we get a note taker.
Oh, you want a pen too?
Oh yeah,
Man,
I'm being hard. Note taker, we need a note taker.
Okay.
Took you long enough, Jeff. We all knew it was going to wind up with you. So this is the mailing list, unless you didn't already know. And our agenda is as follows. So we're going to do core documents. We have 3 of them. And I don't know which order you guys want to do this, and some of you threatened to demo. Yeah. In this order?
I'm okay with this order.
Okay. And then we're going to do extraneous stuff on OAuth too. Do you want to say something about the OAuth?
No, we can leave it as a surprise.
Leave it as a surprise for later, and then we saved some room for people having other stuff to say. All right, who wants to go first? Who's on first? All right. I spent some time working out exactly which slide you want me to present. Is it that one? That's the one. That's like in fantastic luck. It happened to pick the right slide. It's the perfect, yeah.
Okay, I'm Andrei Popov. I'm with Microsoft, and I'll briefly talk about the updates that we made to the token binding negotiation draft and the token binding protocol draft since the previous IETF meeting. We've had, a few new versions of the draft published, but the changes are mostly about, wording, and none of that affects, bits on the wire. So the changes are really relatively minor, editorial, I would say. The first change is the token binding key parameters. So for feedback that we've received, we moved the definition of the definition of the initial set of the identifiers for the token binding key parameters from the negotiation draft to the protocol draft. It makes it easier to reference a specific document, and also it kind of consolidates the description of those parameters in one document. So that's the first change. There's absolutely no change to the actual to the semantics or the meaning of the identifiers. They're still all the same identifiers. And of course, along with the identifiers, we moved the IANA consideration section also from the negotiation draft to the protocol draft. Next slide, please. Another change, so with regard to referred token binding, what we had in the past was that the referred token binding was introduced or listed in the protocol draft, but was really explained in the HTTPS token binding draft. We have received comments saying that, if you are introducing that binding, why don't you have some text describing in more detail, right there in the protocol draft what it does. And this is basically it. So we've added some text that introduces the, the meaning of the referred token binding rather than just referring to the next document. Next slide, please. And more of the same in a different section of the protocol draft. We're describing exactly how the referred token binding is constructed, what we're assigning, and what key we're using. So that's, again, nothing new here. It was already described in the HTTPS token binding. We just, made it so that you don't have to read that other document as well, if you want to understand the basics of it. Next slide, please. So ECDSA P256 signature and key formats. So there are a couple of clarifications that we made to make sure that the implementations are interoperable. We explicitly say that that the integers are 32 bytes and that the leading 0 bytes are preserved, both in the case of the signature and the key. That's just a clarification that we made. Next slide, please. For the token binding ID, we've made a recommendation that a token binding ID is exposed to applications as an opaque byte sequence. Partly, I think the benefit of doing it this way is that the application doesn't have to concern itself with what version of the token binding protocol is it, what is the actual token binding ID format for that version. You just consider them blobs of bytes, and you can binary match them. If they match, they match. So that's just the recommendation in terms of how token binding IDs are presented to the applications. And And we added a note saying that both clients and servers, either or clients or servers, may create bound tokens. Apparently, there are cases where in challenge response protocols where the client actually incorporates the token binding ID in an object, in a signed object that the client returns. This is also a perfectly legitimate use case, and we just made it explicit in the spec. And that's all the updates that I have for these two documents. Now, Dirk will talk about the updates in the HTTPS token binding spec.
See if I can find that.
This is also where you could switch.
Oh, yeah, you wanted to say that. You want the whole white thing?
Sure.
Right.
Sorry. I'm gonna do this.
Okay, do you want me to advance it for you, or?
I'll just
Okay,
sort of do an interpretive dance where I jump back and forth.
I'm good with that.
Okay.
I want to see the dance.
All right. So the third spec that we have is token mining over HTTPS. I'm Dirk. The node sits over there. We both kind of, I guess, sort of edited things. Jeff also edited a few things, and I forget who else. I'm going to compress this a little more, but just like what Andre just said. This round, it was mostly sort of wording changes, I guess, that we did. Nothing normative really changed, with one exception, which is the spelling of the one response header that is defined in the spec. There's a single response header that indicates to the user agent that upon a redirect, as it's following the redirect and hitting the location that is indicated in the redirect, that it should supply that refer token binding that Andre was just talking about, and the spelling of that header was changed in this. And then mostly sort of clarifications, like for example, how many of these provided and refer token bindings can there be in the header, as explained, and especially during redirects, it wasn't quite clear if you redirect and then the URI that you're redirected to then responds with another redirect, do these referred token bindings accumulate or do they not? The answer is they do not. So that's spelled out in here. We now have I think before we just had in the security sort of consideration section, we said it's probably a good idea to scope these keys by ETLD+1. So that's now in a different section where it says, this is what you're supposed to do, and I think also explained in more detail. And if you're really curious, there's a working link in the PDF where you can click and you can see the actual bits. But yeah, high level takeaway is that nothing really changed except for that spelling there. So what I thought I'd do instead of going through all the detailed changes, I show this working, and I'm going to have to sort of jump back and I'm not allowed to leave this box,
No.
right?
There's an electric field there that will
Okay.
stun you.
All right. So I'll be talking, then I'll be jumping over there, I'll be doing something, and I'll come back and talk again and try that. So the Canary version of Chrome, Google Chrome, has support for I believe it's actually this draft that Andre just talked about, for that version of the draft built in. And we also have our own TLS terminators that we have that sit in front of all the Google services, where we also have sort of an alpha version of that TLS terminator, has the server-side support built in also. And so what I'm going to do is I'm going to launch the Canary version of Chrome, and I will point it to a special IP address where we can make sure that we're hitting an alpha version of the TLS terminator before we then go to the various Google services. And I'm going to make it so that Chrome, the version of Chrome that I'm launching, will use that particular alpha version of the TLS terminator, both for google.com and for an App Engine app that I'm running on appspot.com, because I'm going to show one of those redirects between appspot.com and google.com. Okay, so watch me do that. So you can see here that I'm launching a canary of Chrome, and I'm telling Chrome to please go to that IP address, which is where that alpha version of the TLS terminator is running, whenever you want to talk to google.com and appspot.com. Okay, so now I ask the browser to go to google.com. And we can see that the browser and the server must have successfully negotiated token binding, because the browser, when it sent out this HTTP request, included the token binding header. Okay, let's look what's inside the header. Okay, so that's what's in the header. Oh yeah, thank you. Awesome, thank you. And so what you see there is that there's 87 hex bytes of stuff in the header. The third byte, the 00, means it's a provided token binding. The 02 after that means it's an EC P256 point that is 40 hex bytes long. Goes until about the middle of it. There's another 0040 there, which means it's a 64-byte signature. And then the last 2 bytes at the end mean there's no extensions in this. So that's what it is. There's a point, there's a signature, and that's pretty much it. Okay, next demo. So I went to a website that runs on appspot.com, which could be a relying party to, say, Google, and has a sign in with Google button on it. And so when the user goes there and clicks on the sign in with Google button, they get redirected to Google. Let's see what happens when I do that. So when I clicked on that button, this website responded with a 302, with a redirect. And you can see here that it asked the browser to go to accounts.google.com, yada, yada, yada. And it also included this right above the highlighted text here, this special response header in both spellings, the spelling from the previous version and the spelling in this version, because I don't know which version Chrome currently honors. So for good measure, I included both spellings. And sure enough, one of those actually made Chrome do the right thing. Because on the next request that goes out from this user agent, from this browser to Google, there is the token mining header. And you can already tell it's a little bigger than the previous one. Let's look at what's inside this one. And so, yeah, it's indeed bigger. It starts off with, again, so the third byte up there is a 00, meaning that's the provided token binding. And then I think, right, so I think the provided token binding ends about here with no extensions, and then the 0, 1 is the referred token binding that starts after that. And so there's 2 token bindings in here. One that is directed at the appspot.com, and then the referred one here is a repeat of what we saw earlier, which is the one that the browser uses with google.com, what we call the referred token binding. Okay. Does that make sense? Cool. Yay. All right, so that was an update that we sort of kind of have it working in Canary, and hopefully going to be rolling it out soon past this one sort of alpha version of the TLS Terminator to the rest of the fleet. And the other thing that we wanted to report here is that the node has been having conversation with Anne van Kirsten. Am I remembering the name, pronouncing the name right? Who's sort of the editor of the fetch spec over in the WhatWG, and has been preparing a pull request there to incorporate some of this token mining stuff into the fetch spec. Basically, the way to think about that is explaining to browser implementers how token mining works and what they need to do. So the changes in there, the first 2 bullet items you see here, the basic browser flow and the redirect flow, is basically taking what's in the drafts that you know, the token mining drafts that we're doing in this working group, and explaining the pieces that are relevant from those drafts to implementers of user agents of browsers, and putting it into the fetch spec. So it says things like, if you see this response header in a redirect, you need to then, on the next response that goes out, include a referred token mining. This is what a referred token mining looks like, and so forth. So that stuff is in there. It's basically just a repeat of what's in the specs that we're doing in this working group. And then the third item there, the programmatic fetch, what that refers to, and that was actually one of the explanations that we sort of refined in the HTTPS spec, was that we do have support for federation in the specs, but not all federation patterns will be able to benefit from the stuff that's in the spec. So if you have a federation pattern like the one I just showed, I click on a button on the Sign In with Google button, and then there's a redirect that redirects me to Google. Then, as we just saw, the response header is there for that, and it makes the browser then issue these 2 token bindings. That's great. But not all federation flows work like that. Sometimes the Sign In with Google button, instead of issuing a redirect, pops up a window and points that to the IDP, to Google at this point, right? There's no 302 anywhere that gets issued and so forth. So what do we do in those cases? In those cases, we also need the IDP to know about this other token mining that the browser has with the relying party. So the node and Anna have been sort of laying the groundwork for being able to do that with this pull request that the node's been working on, where the fetch procedure itself knows about token binding and referred token bindings, and has an extra flag that says, please also include referred token binding, meaning if you're called from one origin and you're being asked to fetch from another origin, and this flag is set, then include a referred token binding. It doesn't, the fetch procedure is sort of this abstract thing that's happening inside a browser. So as of yet, this doesn't really say anything about particular APIs, how this is exposed in XHR, what kind of new HTML attributes on the form field or something this would correspond to. So that's still open, but the fetch procedure itself, once that pull request gets sort of merged into fetch, we'll be able to know about token binding and refer token bindings and so forth. And then we can have the conversation probably over in the W3C, how to translate that into specific APIs. That was my last slide anyway, and I'm done. Thank you.
So we want to do questions.
Yeah, let's do questions for this, for Dirk and Andre. You know you have them. So if nobody rushes to the mic, it sort of prompts me to, you can ask questions, but while you think about the question, I have one question that then be my guest. So okay, go ahead. Yes, William.
William Dennis. Dirk and I were talking about this yesterday, but I'm kind of curious to hear what other people think about this requirement that it does start with the 302, and if there are other ways to solve that. So if people weren't following that, basically what it means is that instead of having a link on the page, say that's doing the auth request directly, you have to first hit your server, which then 302s to that link, so that the token binding can get included. I'm curious to hear what people think about the impact of that. Whether the answer is simply, okay, so everyone just spins up that endpoint and does it that way, or if there are other ways that we should be considering.
You should feel free to come up.
Right, so because federation is done in many different ways using different patterns, we probably need different triggers for the different patterns that all amount to the same thing, the user agent delivering those two token bindings to the IDP. And what that trigger exactly is depends on the pattern. And so for the pattern where you do have the redirect, the response header that is in the spec is the trigger that seems appropriate. And the spec is silent about what to do in the other patterns. One thing that we did put in to sort of clarify that, because you're not the first one to kind of ask what's going on, is we say specifically this spec only talks about this pattern, and you need to look elsewhere if you're worried about other patterns. So that sentence is now in there. So what are those other triggers and for the other patterns? So again, that's something that will happen in other kind of working groups, but I imagine them to look like this. If you make an XHR, when you click the button and it opens, you fire off a cross-origin XHR. When you create the XHR object, you can set certain flags like include cookies and stuff like that. And so one of those flags would be include refer to token binding, would just be one of those flags, just like the ones you have today for include cookies. What if, like in a SAML world, often what you have is you have this big form that's on the page that sort of auto submits itself to the IDP, right? So another trigger I could imagine is that on forms like that are on pages, you could have an HTML attribute that says when this form gets submitted cross-origin, include token binding. Again, it would just be an attribute that sort of has a true-false kind of value. Maybe something similar could happen on simple links. Like if the button just opens a link somewhere, you could include something like that. But those are just proposals. We should probably talk about them, what that should in fact look like. But since those tend to be, I want to say at the API level in the DOM layer, probably not in this working group, it would be like in the W3C or places like there. And since it's already the fetch mechanism, once the node's stuff has gone in there, we'll know how to deal with requests that say, hey, I want the refer token binding in here, please. Everything below that API layer should already be ready and wired up. We just need to decide on what we want this to look like in HTML and JavaScript and so forth.
And in each case, with each of the different mechanisms, it would be the referred token binding is the page that it started from, and the target. That's the two bindings, is it?
Yes.
So if the link were to include like a
right. So each of these things have in common that there's an origin that from which the request is made, and an origin to which the request goes, right? And if you're in this situation, and this additional flag is present, then you include both of these token bindings.
Cool. Thanks.
Okay. Other questions?
This mic is very tall.
Okay.
So both. So I was wondering, like, has consideration been put in like the other use cases for this, like privacy sensitive? So for example, ad networks might. This is a better form of cookie synchronization if you add this flag. Essentially, like they don't need to implement like cookie synchronization at all. So like the privacy implications of adding this flag of I refer token binding.
Right. So it's a good question, and I forget now off the top of my head how much of this is spelled out in the privacy section. I should double check, or you should read it and see whether you find the answer in there satisfactory. The idea is that browsers already today have notions of when it's okay to send cookies and when it's not okay to send cookies, right? Certain browsers have third-party cookies turned off by default, for example. In other browsers, you can turn that option on to turn off third-party cookies. And the recommendation for token mining is that if the browser is sending out a request in a context in which it knows that it shouldn't include any cookies for privacy reasons, it also will not advertise token binding. So browsers already have this notion of a sort of a privacy preserving way to send a request and a normal way to send requests. And it will only use token mining in the normal context and not included in privacy preserving context.
So if somebody requests to, it would not, if somebody says like include refer token binding, that would not work in a privacy.
That's right. The browser also has to want to.
This is Wendy Seltzer with W3C, and hearing several references or to W3C, I wonder when you think would be the appropriate time to bring this up, probably in the Web Application Security Working Group.
Probably once Anna and whoever else needs to gives the okay on the fetch merge, because then I'm thinking of it as sort of like working our way up, right? What we're doing here in this working group is sort of the network layer, TLS and HTTP. Then the fetch spec is sort of like the mechanics of a browser. And then once that is gelled, we can think about the API surface. Do you have like a timeline? Is it weeks, months? What?
Great, happy to work with you on that. Thanks.
Awesome.
So I have one question. Do you think this is ready to go to working group last call?
Yes.
And we're talking about all three, protocol negotiation and HTTPS all together, right?
Yes.
Right. Does anybody widely oppose that or have believe that there is a lot of work missing? Or do you think you have minor nits that can go into the VGLC process? Then you can still keep nodding, but I want to know if somebody has major stuff they need to go in here.
Mike Jones, Microsoft. I'm not taking a position on that, but just I would ask that maybe you ask that question again after my presentation, because I'm raising an open issue which we may decide to solve in a quick draft or not.
All right, you're saying you're going to raise an open issue with the core specs in your draft. All right, so we'll revisit. But I would like for us to get to a point where we know where we are with the VGLC before we close out today.
So I have another question. We just saw a demo of Google's browser talking to Google's TLS concentrator. I know that Hans Zandbelt has updated or has a version of Mod SSL, which works with Mod OpenID Connect for Apache, that also does token binding for testing. Who else has been working on implementations? Has there been any cross-implementation testing? Because that tends to show up more issues than testing with yourself for some reason.
Andrei Popov, Microsoft. So Internet Explorer uses token binding. We have an implementation of an earlier draft. I believe it's version 3, if I'm not mistaken, of token binding. So obviously it will not incorporate right now with Google services because they implement version 8, right? But we do have an implementation that we've tested between our servers and our clients. And we found it, deployable. So we're willing to go forward with that. As soon as this goes into last call, we're also making an update to the latest version. So we'll test interoperability with Google at that point.
So your trigger for doing the update so we can do cross-vendor testing is last call?
That would help.
Sounds like a good reason for last call. Next.
IE and Edge, they both use the same HTTP engine, and that's
Good man. Will it also be supported on XP?
XP is not a supported operating system. So.
Subodh Iyengar, Facebook. We've started working on implementation for token binding, and yeah, so we'll give feedback when we have more.
Next.
So, are we doing Brian or Mike first? You want to do Mike first? Okay. Let's see if I can find your magic slides. Could that be it? Could that be it?
That would be the one. Good afternoon. I'm Mike Jones from Microsoft. And knowing that token binding, all 3 specs are pretty mature and pretty implemented, before they were done, I wanted to write down proposals of how you could actually use them end-to-end in, for instance, Federation for OpenID Connect, for OAuth access and refresh tokens. And next slide. And for 2 purposes. One, to just enable end-to-end interop testing of those scenarios, including possibly cross-vendor interop testing. And the other was to identify whether there's any gaps in the core token binding specifications or not. And the teaser, which I already said for the mic, is I think there's one gap in which I'll go into in a minute. Next. So I'll talk about the 3 kinds of tokens separately, and then Brian will come up and talk about another kind of token binding for OAuth. The simplest case is actually OAuth refresh tokens. Why is that simple? Because there's only 2 parties. They're communicating on one TLS connection, and the authorization server can just add token binding information to the refresh token or associate it with it. Client doesn't even have to know it's there. When the client sends the refresh token back to the authorization server, it can check the token binding information that it already associated with the refresh token. Life is good. It's transparent to the client. This is sort of analogous to the cookie case. Next. Oh, Dr. Secure.
Yeah. Tony Nadlin. So if the session got torn down in between, the client doesn't have any understanding of that the things have potentially changed. The token ID may have changed out from under them and stuff like that. So they have no notification of what's going on here. So you're going to get lots of re-authentications possibly.
It's true that if the token binding ID changes during the lifetime of a refresh token, you would get an error on a token request using the refresh, and you would possibly have to do a new authorization request at the authorization endpoint to get a new refresh token, Dirk.
Dirk Balfans, but I would point out that doesn't happen just when the session gets torn down, right? The token binding ID is longer lived than SSL sessions.
Somebody resets it.
So
Right, so the client would have to, token binding ID corresponds to the key pair that the client controls. So yes, if the client resets the key pair, my hunch would be that that is sort of a similar similar event as the client just like forgetting the refresh token to begin with, because they'll probably be maintained in a similar fashion. It's a guess. I'm not sure. Okay.
Thanks, Tony. So the next easiest case, as it worked out, was the one that the token binding HTTPS spec already covers, which is when there's a 302 redirect between an identity provider and a relying party over two different channels. So in this case, there's three parties using two TLS connections between the user agent and the relying party, and between the user agent and the identity provider. And as you're all probably already familiar with, you can trigger using the mechanisms that Dirk was just talking about, sending the referred token binding of the connection to the relying party and send it to the identity provider. So the identity provider can then put token binding information in the issued ID token, which is sent eventually to the relying party on the channel between the user agent and the relying party, channel 1. The relying party can validate the token binding information in the ID token, and all of a sudden you have an ID token that's only usable by the correct party. This was all anticipated by the working group, and it seems to work out well. Next slide. I'll give you one slide of sort of a design choice that we made, which I've talked with some of the authors of the token binding specs with, but I wanted to bring to the attention of the whole working group, which is rather than putting the token binding ID in its entirety in the ID token, we made a decision to put the SHA-256 hash of that value in the ID token. It only saves you about half the space for elliptic curve, but if you're using a 2048-bit RSA key, it's a really significant space reduction. And given that ID tokens are used in space-limited environments, we thought that this was important to do. This also parallels some things that are done elsewhere in OpenID Connect, where we have cryptographic hashes of access tokens and of authorization codes. So this is another kind of cryptographic hash of a data structure that's carried in the ID token. So I will say, and I think I know how to solve this, but I didn't do it in the 0.0 draft, in order to satisfy normal IETF criteria, we'll have to work out how to have crypto agility rather than just one hash function. And talk to me offline if you want. Brian.
I was just going to probably say what I think you were already going to do there, but isn't just defining the confirmation name sufficient, and some text about new ones could be defined with that use other algorithms in the future? Would that be sufficient?
That was my thinking, that we apply the same trick that we used for the thumbprint X5T,
yeah.
that X5T uses a particular hash function, and you would use a different name that's algorithm specific for a different one.
Got it.
So another draft. Thank you. So token-bound access tokens are where it actually gets interesting. And remember that access tokens are core to what OAuth does. Why is it interesting? There's actually three parties involved in the communication, just like in the federation case. But sometimes there's three TLS connections, not two, because the client has connections to two parts of the authorization server, the authorization endpoint and the token endpoint. And in fact, some clients are architected such that those connections might happen from different places, maybe even different hosts. And so life is a little bit harder. And I should say up front, I should have said it on the slide. I thought I did. That. Oh, no, that's the next slide. I'll talk about the problem on the next slide. Right now, I'll just talk about what you would do to get a token-bound access token. So the flow, starting in the third bullet, is the client figures out what the token binding info is for the connection to the resource. Note that this flow didn't start at the resource. It starts at the client. So the client's going to have to sort of pre-establish the TLS connection to the resource to get the token binding info. Or Andre told me another trick that can also be used, which is described in the draft. So then the client sends an authorization request to the authorization server on its connection to, which is to the authorization server, containing the token binding information for the first connection. So that looks a lot like the federation flow. And for now, we're sending that as an explicit request parameter in the OAuth authorization request message. Then the authorization server puts what would have been the referred token binding info into the access token, or associates it within a private database of some kind, but it's logically in the access token. Sends it to the client. The client then uses the access token in the normal way at the resource, and because it contains token binding information for connection 1, the one to the resource can look in the access token or introspect it and figure out, was this bound to me or someone else? So in a lot of ways, this is like the federation case. But on the next slide, if you have a clarification question, I want you to say it. Otherwise, let me go to the next slide and then do your question then. So next slide. The issue, which I think you've already figured out, is that this is not using a 302 redirect, nor is it using what the fetch working group will, or what the working group will do with fetch. It's not happening in the general case in the browser. It's happening often on a native client implementation, maybe, you know, on your Android phone. And so that native application is talking directly to the resource and talking directly over different channels to the authorization server. There is no browser in many of these resource use cases. So the browser 302 functionality, while good for federation, doesn't finish the story. Effectively, what the deal is there's cross-domain communication, but it's happening explicitly because the app is doing it, not because the browser is doing it for you. Therefore, as currently written, there's no referred token binding sent, even though logically that's what you want to have happen. So instead, we had to send the token binding info explicitly using another parameter rather than communicating it in the way the referred token binding information would. Now, Andre and Dirk know more about this than I do, but I think one of the problems is that means that the two channels are not cryptographically bound together in the same way that they would be with, for instance, the 302 redirect functionality, Dirk nods. So the proposed solution, which I'd like the working group to discuss, is to put a requirement in the protocol spec that implementations provide applications of the API a way to provide referred token binding information from one channel and send it as referred token binding information to the other. Now, the good news from a requirements point of view is if you're going to implement the HTTPS token binding spec, and it's using an API that the core provides, the core is already providing that. Now, I am explicitly not trying to say how should particular platform APIs do this. So I do not want to talk about syntax, but I am proposing a functional requirement on token binding implementations that the API implemented is required to enable providing referred token binding information. This gives applications the same functionality that the 302 case does, that the fetch case needs, etc. I'll also point out that this problem and solution, we think, also applies to the OAuth token exchange use case. I think it applies to a lot of other protocols in which you're not doing redirects through a browser, but you're explicitly using multiple channels from the application. There's a big queue.
William Dennis. With the so when Dirk and I were reviewing this yesterday, actually we had a question around this, and that is if the app is actually just setting, it can set whatever headers it wants on that request. So couldn't the app include the referred token binding header?
It's at a different level of the implementation stack. There's going to probably be either a system provided token binding implementation or a library that you're using, and you need an API to call into that library or system interface to say, please use the token binding information from this channel and send it on that channel.
So,
which I think is probably the biggest open question I have with this right now, that like which layer does this sit at?
I am not saying how to structure your implementation.
Yeah.
I am saying that whoever calls token binding needs to have that available to them.
I'm very glad that we brought this question up. I think it's a good one to solve, perhaps at least before we put the federated spec into last call.
Well, it's actually a requirement on the core protocol. It's something that the federated spec uses. So the good news is the core protocol already pretty much has to provide this to however the federated spec is implemented. But my point is you need to make that available to native apps as well.
Andrei Popov, Microsoft. So from my perspective, the protocol spec describes the protocol, right? The protocol allows this. The question of how the APIs are structured will be very, very specific to each platform. It's clear that in order to implement the HTTPS token binding spec, you have to have the functionality of generating both provided and referred token bindings, and there's definitely some API at some level that provides this. If the OAuth token binding spec has additional requirements for the platform, to support certain APIs, it's okay to include it in the OAuth spec, but I don't think it should be part of the token binding protocol spec itself.
I'll respond to that after I hear a few more questions.
Yeah, this is not a question. This is a reply to Andre. Jeff Hodges. RC 5929 channel bindings does have this sort of section. It's section 7, which is API guidance. I think it's perfectly fine for such a spec to have API guidance in it in general terms, and is appropriate. And there is an example that's out there and went to RFC standards track.
So Andrei Popov again, definitely there are precedents, and I'm not strongly opposed to it, but I believe that it's unnecessary in the current spec because it's a requirement imposed by a different document. So if OAuth requires this, then why don't you define this on OAuth? And the implementation is compliant with this specification, we'll have to implement it. Because the problem is, if all you want to do, if you want to just implement a web browser with token binding support, then you don't necessarily need those additional requirements, don't need to implement those additional requirements.
Okay, now I'll respond. Part of the problem is that if it's not an API requirement, as Jeff said, in the core, then there may be implementations out there that conform to the protocol spec, but make these use cases impossible to build. And if, wearing my OAuth hat, if I can't count on the core giving me that functionality, I may have to not use it. Whereas most of the implementations are already going to have it. So the interoperability of the ecosystem, including for Microsoft's native apps, right, is on multiple platforms, because we write for many platforms, is improved by putting the API requirement there.
Dirk Balfans, Google. Couple of, I guess, thoughts. One is that the specs as currently written don't mean to imply that the only way to issue a referred token binding is through this 302 redirect mechanism, right? This is just, we just say, here's one way that will cause a browser to do this, right? It's sort of, at least in my head, implied that you can put as many referred or whatever token bindings if you want into this data structure, right? So if that wasn't clear, maybe we should sort of look through it again and make sure that that's comes through. The other thing is that if I look at the implementations that I've seen so far, is the token binding stuff itself tends to live right with the application code. You basically use OpenSSL, you pull the EKM out, EKM out of there, and then you make your header and then you send it off. So to me, saying a client should be able to put a referred token binding in there if it wants to is stating the obvious.
Okay,
but I don't mind stating the obvious in our specs.
Yeah, I would love to just state the obvious in the spec, because I don't think I'm asking for something that people aren't already doing.
Yeah.
It's just, I think we want to give guidance to people building this implementations that, yeah, you should do this obvious thing. So this isn't making work, this is just making interoperability better.
Tony Nadlin, I don't think you can put the requirement on the implementers to provide the API. Platforms are going to do what they want to do. If they provide an API, that's fine. You can use this because this is an optional thing of OAuth. This is not a requirement of OAuth. And so just let the platforms do what they want to do and be done with it. And so I would, it's hard to accept this requirement for the platforms to provide this API.
I would respond to that saying, though, that to the extent that we want to base cross-platform security on token binding, we need the different platforms that are communicating to all make this possible.
What you just said is not right? Because we can do it through token binding. You're asking us to do it through to the access tokens, which is different. Okay, so we can do platform interoperability with token binding as it sits today. It's the usage of the access token that you're asking for, not token binding.
Yes, it's for an application use case that I think is representative of a bunch of use cases.
Thorsten Boderstedt, I'm totally confused because I think the requirement or the question Mike just asked is very similar to your programmatic use cases. In your presentation, you just said there are some use cases where the client, the web server, can indicate to the browser, hey, please add this referred token binding header thing. But there are other use cases where this is not possible. Okay?
And I think what Mike is asking for is there should be a mechanism to query the data and to inject the header, or just tell the platform, please inject this header. That's it. And from my perspective, without this functionality, this whole stuff is useless.
So this is Dirk again. Maybe I'm the one who's confused. So the way I understood, and disclaimer, I'm not quite sure I followed the previous slide here. I first thought when you said client, 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 I was thinking browser, 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 but then you said it's not a browser. So when you're thinking about a browser, then the programming environment that you have is like JavaScript, HTML, and so forth, right? And you don't get to see what the EKM is. You don't get to have fine-grained control over your connections to places. You don't even get to say what headers are going to be included to your requests to certain origins and so forth, right? So at that, if your control is at that level, right, you definitely need to give some lever so that the client code can say, yes, I need that refer token binding in the outgoing requests, right?
Yeah, that's right.
But I think what Mike is talking about are sort of clients that are like native apps on mobile platforms or something, right? That's an example, yes. Open a socket and I make all my HTTP headers by hand manually. And so at that point, it's obvious to me that I can put as many refer token bindings as I want in there because it just grabbed the AKM and then I just put it in there. And so that's what I meant by this seems to be stating the obvious that should be possible if you have that level of access to your networking stack. The app has the keys, right? I would assume.
So as a point of clarification, I think when the authors were working on this, there is sort of a middle ground where you may actually have this functionality included in the operating system. So yes, at the moment, it's not part of the operating systems, but if vendors provide secure element storage, etc., as part of the platform, what things should they expose to the applications so that you could have minimum functionality?
Yeah, so I could imagine that there's an operating system that tries to hide this stuff from you and says, we're going to put this token binding header in outgoing request for you. You don't have to worry about it, right? Or we'll maintain the keys for you. You don't have to worry about that.
It's not necessarily a bad thing.
No, it's not a bad thing. I was just saying that the implementations I'm familiar with right now, they don't work that way, but I can imagine platforms doing that. And if platforms do that, then yeah, they should definitely do what Mike is asking them to do.
Right, so that amongst the authors, the conversation was, given that we may have different environments, should we provide guidance to people who may be building it into the lower levels of the operating system into secure elements, say, these are the sorts of things that we would expect to be exposed to native applications in a sort of a broad functional way, as opposed to, this is what the API has to look like, but we expect the functionality of being able to send a referred token binding to be exposed to the JavaScript layer at some point. This would be a similar sort of statement. We expect the functionality of being able to use a referred token binding header ought to be exposed to a native app in some way. Now, to my mind, that's actually a separate question from whether or not we should actually use referred token bindings. I think that they're related, but not the same questions.
So I think that my question is following up on that point, essentially. So this actually, I think, is underspecified as well. So for example, what does it mean to be a token binding implementation? Is fetch, if the application requires, is the fetch API the right level at which to provide? So it might be undesirable to provide a browser to provide the application to be able to supply the referred token binding information completely for security reasons. And so does this actually mean that everyone at every layer?
No.
So what does it mean to be, essentially, what does it mean to be a token binding implementation? Is it the API? Is it the implementation? Is it the low level library? Is it the operating system? What does it mean to be a token binding implementation?
I was thinking providers of the functionality in the core token binding spec. which, for instance, the HTTPS token binding spec is a consumer of that, so the requirement wouldn't apply to that. And it wouldn't apply to fetch, but it would be pertinent to software implementations upon which you would build HTTPS or fetch or OAuth. And I agree. And this is just slideware right now, that we would have to write down some tightly crafted paragraphs for API guidance.
Nick Harper, as a browser implementer, I'm a bit confused what this requirement means for what I'd have to do.
For you, nothing.
Okay.
For a browser, nothing.
Yeah, so that's not at all clear here.
Thorsten again. I personally think it's not necessary to really expose the key material to a client and to force them to really add the security headers manually. I was rather surprised to learn what your expectation is. But I have to talk to my developers about whether they're really gonna hand code all this stuff on HTTP connections. So my expectation, or what I would assume, or what I could envision is that the client is given an option just to say, please, HTTP client, if we're gonna issue a call to this URL, please include the token binding ID that belongs to this URL.
Right, that would satisfy the requirement.
This is totally simple, right? But it would mean for your specification, for example, you would no longer use an explicit parameter, but rely on the underlying HTTP transport to carry.
Yeah, again, per my answer to Tony, I'm not saying how the API should look.
Yeah.
I'm making functional statements, not API statements.
So just to insert myself into the queue a little bit here. So Mike, wouldn't it be reasonable when you wrote up, or when somebody writes up the implementation of the specification of how to do token binding for OAuth, that you include the API requirements for that application? I think this is Tony's argument, right? You put those requirements into that spec, right? And as much as like when Vinod goes to talk to the fetch people, and you know, here's what you guys who play with JavaScript will have to do, right? That goes into that pile, right? So how is OAuth different? Do you believe? I mean, one possible answer that could be, well, I believe that, you know, doing this little text tweak enabled many more things than OAuth, right? But if it's just OAuth, or if it's just sort of that type of application, you might as well stick that in your specification.
No, and I don't think it's just OAuth. I think it's any application that's communicating explicitly across multiple TLS channels that's not using a browser to mediate the communication.
Right, but I think Tony's point, and I sort of have, it's hard to stipulate compliance with something when it's not tied to achieving a specific goal, right? I mean, so if you're doing OAuth, right, then you can say be compliant with the OAuth token binding spec, and this means doing this, and that, right? The OAuth protocol is just a way to signal certain data types and data objects, right? How, you know, again, this is just my personal view. I was just lazy, didn't want to go up to the queue, but to me, it seems like you have to have a reasonable answer to that question. As why is this so different from any other spec work?
I don't think it is different. That the base spec should define minimum functionality, which specs building on it can count upon. The additional spec shouldn't have to augment the minimum functionality in order to work. And I'm worried that if, for instance, OAuth has to augment token binding, it won't always work.
But keep it going. I mean, we have plenty of time. We can argue about this all day. But at some point, you know, it would be great to get to the point of asking the question whether we're actually done. And we have Brian to listen to too.
Dick Hart, Amazon. A couple questions. One, first to the token binding authors. Was the intention of token binding to be a general solution for binding any kind of bearer token to the TLS channel?
Andrei Popov, yes. So the basic token binding protocol is supposed to be applicable to any kind of tokens, yes.
And so then, you know, one of the ones is cookies. It's kind of easy and straightforward to do. Another one is what's happening in OAuth, but it would seem to me there's potentially going to be quite a few other types of applications going to use this. And given that it's intended as a general purpose thing, I think some guidance, as Jeff and Mike are pointing out, that there should be an API for applications to get it seems to be a good thing.
Thanks. Relaying for Justin Richer from the Jabber room. He says, this is all about non-browser-based HTTP communication. You can do it with the current spec, but there ought to be functional guidance so non-browser apps can do all this the same way. There's no reason for OAuth to be a special snowflake here.
William Dess, that was going to be my point too. So I agree with Justin and Dick on this. I think this is actually, we're talking about referred token binding. We're not talking about OAuth here. We're saying that in order to use referred token binding, then there are certain things that are required. And I think to distill Dirk's view and Torsten's view, effectively there are two ways you can do this. One is where the application is adding everything that it needs to do, adding all the headers, managing its own keys and doing everything. Or you have a TLS stack that your app is using that has an API that lets you do it. Those are the two choices. Effectively, one is the TLS stack is doing it, and one is the app is managing everything itself. And I think, to Mike's point, what we want here is guidance on people creating a TLS stack for use in applications that it will need this API. And this is not for OAuth. This is for token binding of referred tokens.
That's right, for any application with those characteristics. This is not OAuth specific, which is why I came to this working group to talk about it.
Right, and so I think if a TLS stack were to implement some token binding for the non-federated case and not have the federated option, it would mean that an app wouldn't be able to use the token binding implementation of that TLS stack and instead would have to implement it itself. And actually the requirements to implement it yourself also add APIs to that TLS stack, like you need to be able to pluck out the keys and install them yourself. So either way, there are APIs that have to get added to these TLS stacks, and it seems to me this is actually the safer and more sensible one to add. Yeah, thanks.
Tony Nedlin, you know, up here it does say that you require the token binding implementations. You know, if you're asking for guidance, maybe that's okay, but this is an optional thing that the platforms may or may not do for referred token, you know, for referred tokens, and it's the platform's choice whether they implement this or not, and they can still, you know, things will still work up to a point.
As long as you don't need referred.
That's correct. And referred's an option. It's not a requirement of that you need this feature. So, you know, Stack's going to look at what their resources are and determine, you know, why do I need this and why do I need to spend the resources to do this API, and then have to support that API for the life of it.
So Mike, I'll sneak in the line just quickly. So part of our thinking around this in the debate that we had was, and we knew that this would probably be controversial, which is why we wanted to bring it here. We have two design choices. It would be much cleaner to use the referred token binding, but it's unclear that native apps will actually have access to that referred token binding. Also, in situations where the client is a cluster or in some ways distributed, it's unclear that the client would have a monolithic view of its private keys to be able to do a referred token binding. That's perhaps an edge case for some large servers, but some people will run into that. If we took the path of passing it as an extra parameter, it's unclear that it actually decreases the security very much, and Dirk will have an opinion about that. But you either trust the client or you don't. There's some other OAuth issues around that. So if a client chooses, or an OS or whatever the infrastructure chooses not to support referred token binding, if we pass it as an extra parameter, then you could still do token binding for access tokens. If we have an agreement that referred token binding is going to be available to native apps, then perhaps the pendulum swings in the other way, where the advantage of knowing that a lower level of the TLS stack, not the application, actually is attesting that it controls both of those IDs. So it's, one is probably more likely to be generally available and support, the extra parameter is going to run into fewer road bumps, but it would be easier for developers and to have the referred token binding because you're pushing it down a layer.
So Martin Thompson, when I heard Torsten's formulation of how you might approach this, I think that made a lot of sense. And it sort of made me question, is this asking for a new API in addition to the include referred token binding thing that you flagged that you're talking about at the moment, or are we talking about a different API?
This would be an API available to native apps. The API for the HTTPS token binding is the 302 referred header, which doesn't exist in the case where you're a native app.
So the suggestion here was that you're not necessarily involved in a redirect in some of these situations.
Right, there is no redirect. It's
Yeah,
a native
so
app making two independent
why
calls.
Why is this not applicable also in the browser context?
It is applicable in the browser context, and the W3C and the fetch stuff is going to have to sort out how that happens.
So what I'm trying to get to is why is this not simply looking at this from the perspective of, we have this very simple API and maybe it just needs a little bit of enrichment, and then we can achieve what Mike seems to be looking for here without additional work.
Well, I think the problem is that we don't actually have any API that's defined for a native app to use token binding.
Well, I'm talking about fetch. I'm thinking about this.
Right, but fetch.
Let's abstract up a little bit. I'm thinking about this from the perspective of someone who is presenting an HTTP API to someone consuming it. And fetch is a good embodiment of that because it's the one that I understand, it's the one that I can write code for. But this exists also in the native application space as well. I mean, that someone's providing with an HTTP stack that somewhere buried in there is some private keys being generated and being used for this sort of thing. What am I going to present in that context as well? Now, if the suggestion is that you might want to talk about private keys that client doesn't have access to, that makes me a little bit nervous. But if it's simply, I want you to use the private key for this origin when you make a request to this origin so that origin can then bind the tokens ultimately to the first origin, I think that's actually a much cleaner way of talking about this and avoids the questions about redirects and all those sorts of other things and sort of simplifies the model, makes it very clear what sort of authorization decisions have to be made if there are any to be made. And it means that we're talking about one API and we're making one request of the fetch folks when it comes to that. It's a richer interface, but that's what we have. I thought that was empty. So I think it complicates the implementation in the case where you are relying on a redirect, because you actually have to stop the redirects. You have to manually go in and say, oh, I've been redirected. I'd like to now make a second request and please use the origin for the first one. If you have only that API, but I think it might be a cleaner way of thinking about it.
So I guess the authors were and are unclear on whether or not the fetch API is intended to be exposed to native applications as opposed to simply being internal to browsers.
William Dennis with 2 comments. So the first is that this is not really a normative thing. This is just a best practice suggestion for an API implementation. So maybe it doesn't have to be that controversial. The second thing is to your comment, John, you're saying that the app, it's easier for the app to include a token binding parameter. But that implies that the app can look down at the TLS stack, pluck out the key, hash it, and then add it as a
No.
It gets the token binding ID, not the key.
It does not get the key. It asks the lower level to do the things you're talking about. It certainly, we're not asking for it to do it itself.
I guess the point is, if an app can get that material to put it in a parameter, it can surely get that material to put it in a header.
The parameter may be as simple as, I have a handle for a TLS connection, and I call to send a message on another TLS connection saying, please insert as the referred token binding information the token binding from the handle I'm providing, and all of it's hidden. I'm not asking for apps to get into the key space. In fact, a lot of the purpose of these APIs for token binding is to keep apps out of that space and to let professionals do it.
So
I think
William,
a parameter, whether it's a parameter or a header, you need cooperation of the TLS stack.
well, yeah, there's an important
right.
distinction
So
that,
wait a minute. If we need cooperation of the TLS stack, then why not just do it the way that's already been documented? In other words, federated token binding.
well,
Like either way, you have to get cooperation of the stack. So
Because federated assumes you're in a browser.
I don't see that.
so one of the issues that you identified was that an application may actually be using two different TLS stacks for different connections, because that is not uncommon on Android, unfortunately.
Not on the back channel though.
Hmm?
Not on the back channel.
Right. Well, maybe.
Anyway, I just want to make the point that that parameter or header, you have to cooperate with the TLS stack. And if you're going to do that, we may as well use a method that is already.
Header, you only need to have, the application only needs to have access to the token binding ID. If it's a referred token binding, the key is actually being used to oversign the EKM, so the application or the TLS stack has to have access to the private key as well. They're not exactly the same thing.
But it still needs to cooperate with the TLS stack in both cases.
So
I think both
with the
imply-
token binding stack, not TLS.
Well, I think both have implications on the API is what I'm saying. I don't think that the parameter somehow magically solves that problem.
I think that we need to agree that something needs to be exposed to the app, otherwise it can't do anything.
Right, which is my point.
So the question is, what is that thing, and should we agree on it in some way?
Well, and given there's already a spec for it called federated token binding, that would seem to be.
But that's
But
not,
it doesn't solve the OAuth case. I'll talk to you offline on this. I don't want to try to take up the whole rest of the time, but this does seem like a productive conversation.
And so just to remind people, and I think we should cut the line after you guys are already there. But it seems to me that we're arguing about whether to put in 1 or 2 lines of guidance. That's the best thing you can do anyway, right? So I'm gonna sort of loop this back into the question of, can we do this during working group last call? Can you provide suggestion for 1 or 2 lines of guidance text that goes next, probably somewhere next to the federated token binding text that says, and there might be other requirements your API should be sort of not to play. Your API should play nice with applications. That's essentially what you want to say, right? And can you provide a suggestion for text like that during working group last call, or is this a bigger issue? That's my question.
So there has been a request go to the someone for an actual API that will be standardized, and that guidance needs to be respected by that request that we send out.
And that's
So
Vinod's work, right?
think-
That's what Vinod is doing, right?
Yeah, and so we need something more concrete than that, I think, because we're going to actually provide an example that has to meet this. And I think having a little bit better than, we should be responsible here, I think, for deciding the properties of that API so that we can make a reasonable recommendation in that context.
Vinod Anupam. So the proposal that we're sending to Fetch Group covers exactly what you want here, Mike. I guess the big question is, do you want us to say that every client has to implement that fetch implementation versus it's optional? Because the fetch implementation essentially is, there's 2 forms of doing token binding. One is do the provided token binding. The second is do the referred token binding. And in both cases, we prove possession of the key. So if what you're pushing for is one, use a token binding header where you don't prove possession, that's a completely different ballgame. If it is alternatively, that we require every implementation to implement fetch as well, that's a different conversation.
I'm not asking for fetch. I'm asking for a functional requirement, not an API.
So in certain situations, you could think, sorry, so both. In certain situations, you could think of this actually like introducing, like being able to specify a token binding and a key, like introducing like security vulnerabilities in subtle ways. So one use case is, let's assume that fetch allowed an API to like specify the referred token binding. For instance, you could like inject a key and you can inject like, this is my signing key and this is my token binding. And let's assume for the case like fetch also as this API. Now this is kind of crazy because like what happens is now like XSS hole on the website could now result in like somebody joining his attacker joining his credentials to the user's credentials for the referred website. So this is obviously like a straw man, but nobody will implement this. But there are these subtle cases where like if the app is allowed to kind of like specify these token bindings that are referred, it could basically cause security vulnerabilities. So it should be like I agree with Andre, I agree with like Dirk, and kind of like the application should specify the way that it thinks that authentication should be done. And if the implementation does not give an API that the application needs for it to perform its activity, like the implementation should like give that API. Like basically it should be as an implementation for that. But it's not true for all implementations. It's not true, for example, for fetch. It's an implementation of
Fetch is a layer on top of
right. So it would be great if like, so one alternative is to qualify like what is a token binding implementation and like what level it is. So basically like this is very general. Essentially, I understand like implementation is.
I agree. This is slideware. Anything that we would put into the paragraph that Jeff described has to be a lot more locked down.
Right. API guidance is awesome. I'm all for it. And it's just like requiring like this API amongst all token binding like layers is really too far, I think. Like is maybe like, okay, it should provide.
That's
like,
a question for the working group. I'm not presuming the answer to that, but I did want the working group to know that for any implementation where that functionality is not present, it's not really general purpose anymore.
Thank you.
Jason Nichols, Time. One of the points I wanted to agree with is that if we have to implement as application developers on top of the TLS stack and we can't rely on the TLS stack exposing the API, then it's going to become a tremendous problem, especially for native apps and other application use cases where one might have it, one might not. Fetch is not going to be the only implementer of this. So for an application code to not be portable.
Right. So the point was, somebody made the point that, I think it was you, Mike, what you're looking for is functional requirements that something like fetch could point to and say, we're implementing that, right? Does anybody feel that they could formulate such functional requirements and provide them as text? Just to be stupid about this, Jeff?
I would volunteer to work with Jeff on it.
And I'm looping back to, do you guys believe that this is a working group last call thing, or do you need another revision of the document?
Well, my question to that question is, do you want to try to get a sense of the room, whether to do this before working group last call or not? But you're the chair, you decide.
No, that's a certainly, yes, Tony. The fact that I cut the line on the mic for a long time ago, nobody cared. I don't care.
Nobody cares.
I know, whatever.
Tony Nadlin. So this is only if you're using referred. Token binding will work without this feature, okay?
For certain use cases.
That's correct, okay?
But
We already said that.
Tony, that's a matter of formulation. If somebody writes text that says, if you're implementing referred, then you also probably should do this. Right? That's right. That's not a big deal, right? All right. Should we hum on whether people actually want to have functional API requirements?
Well, let's try guidance first.
Yeah. So first of all, let's start by trying to figure out how many in the room actually believe that there is a gap here that we need to fill, right? For people who actually believe that Mike has a point. right? Now. People who believe that Mike's full of it, and we should just sort of keep going with other things. No, I mean, I'm in this specific instance.
Those are separate things.
Who think we should go on with our lives and finish this work without taking this point into account? Now. It's like a 50-50 thing, actually. If he was humming polyphonically, and I don't believe he can do that. Yes.
This is Brian. In a way, I think that the very existence of the referred token binding implies at least the potential need for this kind of functionality by whatever's under it. And I think part of the problem with API and implementation is because it's always hard to define what that is, but particularly when we have something like this that really spans multiple layers, we all have really different ideas of what that API will be like. And Dirk's point about like, oh, the people I know that are doing it now are slapping this header on that header. That's because there aren't libraries available yet. And those are yet to sort of coalesce and be built. I don't know what they'll look like yet. And I think we all have very different ideas of what they might look like. So while I think actually Mike is full of it, I do think there's maybe just some clarifying guidance about what it might mean that could be provided that doesn't really change anything normatively, and makes the part that some of us think is already explicitly implied more explicit.
Right.
That's sort of rambling.
Right. So who here believes that normative, who would be okay with having additional non-normative guidance on APIs? Right. Who believes it would be evil to have such guidance? All right. All right. Now, the one thing I'm going to ask is whether you believe that the document is actually ready to work for working group last call, and we can do that guidance in the WC.
Stephen
Yes.
Farrell. So, Leif, I have to say, if there was a prize for the biased way to ask questions, you've just won it twice.
Excellent. I was going for it.
It's not clear that you could get a real sense of the room by asking that way.
It's not clear to me that there is a real sense of the room to be had today, actually. I believe that a lot, we're arguing about a very, very small, we're in the bike shed business here today, I think. And I think we're arguing about a relatively small number of bytes in the text. I don't believe that when these things sort of get proposed that people will actually oppose them. Martin may disagree here, and if so, I think that might actually be helpful if you had substantive disagreement.
Yeah, so Martin Thompson, I need to think this through a little bit more, but one of the sort of core protections that relying on just having a redirect flag, essentially, is that if a site never redirects to another site, then their token never gets made available to that other site. And we're talking about sort of describing an API where sites can say, well, I'd like you to include the token for this site in the request that you send to me or send to someone else. And I was somewhat nervous about the properties of the privacy properties of the original design, and was satisfied by the argument that, well, the redirect is happening anyway. They could just pack anything they wanted to that redirect and send whatever information they want across in the redirect. But when there's no redirect happening, and there would be no redirect happening, that makes me a little bit nervous about the
Okay, but the thing that's parallel is for these native applications, you're already communicating to both parties or multiple parties.
Are you?
Yes, the applications exist. We're trying to improve the security of those applications by token binding existing communication patterns.
Well, what if I want to say there's the same HTTP substrate being used by two different applications, and I want
It's
and I'm
TLS.
not sure,
It's not necessarily HTTP.
well, TLS, HTTP, whatever, some lower layer that's being used, and I've got an application sitting on someone's device,
and it wants to know whether or not some other application exists on that device. And it knows that if that application is present, it's talking to x.com. Maybe, let's not use a bad example. It's talking to an x.com, and it simply says, please send a request to me, but include the token binding key for x.com, right? And we don't want that, because now it can probe for the existence of that application. Because if the application's not there, it won't get a token binding.
It's not token bindings
so
for
on.
other applications. It can only use token bindings for connections that are already established from my application.
That's unclear.
Certainly not in the case in the browser. If we were to put something like this in the browser.
No, I agree with you. I mean,
Now, we
I'm
can
not
solve that
saying-
problem by synthesizing one in this case, but and including one no matter whether there was one in the first place or not. And that may be the right way to deal with that. But it does actually provide a linkability property then by saying that when you include the token binding for x.com, you now know it's the same person that was operating in there. And that's not cool.
We haven't cut the queue yet, right? Okay.
I gave up on
this
that.
is Dirk. So
That
whoever
was a
is-
long time ago.
Whoever is preparing those two sentences, why not include something like, please make sure clients can do this, and please make sure you're not screwing over the user with respect to privacy.
Well, that probably goes into privacy considerations.
Okay, so maybe the two sentences go into different sections. Okay. I don't know.
Same topic. It really becomes then, I think what Martin's getting to is a question of scoping of the keys. And if token binding itself is a global function provided at the platform layer, then there's all kinds of horrible things that can happen with applications discovering each other or sending unauthorized information across. So perhaps some guidance about scoping within the API is necessary as well.
So Stephen, yeah, I mean, so one concern I have is it might be rather easy to write some sentences, giving guidance about the existence of APIs, but in the general case, it's not clear to me right now, at least, that you can write the security or privacy considerations associated with that for the full generality of what everything that could be done here is. So, well, the two sentences might be quite easy to put in, say, we'd like to have this. The consequences of having that might be something that's not really knowable now, and that might be a problem in this document.
I mean, the reason I'm sitting here trying to sort of push the working group forward is that I think we're arguing about making a hypothetical argument about hypothetical text. It might actually help us if we had text, and then we can talk about it. And either we agree or we don't agree.
Right.
Simple as that.
Tony Nadlin, I was going to say the same thing as Stephen. I'm not in favor of putting sentences in without understanding all the security considerations that one may have against those sentences and what the application could do using that API and stuff. And you're possibly giving the poor guy some ammunition to open up a big hole.
Right.
Or to token bind their access tokens.
So very last person and we're going to summarize this.
Andrei Popov. So the privacy concern, I think, is very valid if we put in vague text, right, obliging every token binding implementation to disclose token binding IDs for all the connections. That would be bad. I think there are definitely solutions for that, such as we can isolate the keys, and that's there is actually already a section in the security considerations about that. But I think it's very difficult to formulate this. In the base token binding spec, it's very difficult to put coherent text that Mike wants. But if we see, we can make that effort basically and see what comes out.
Right, and I think that's sort of up to Mike and maybe I've seen Jeff volunteer to help. You guys would have to come up with something, right? And then we'll see if the working group accepts it or not. So my question now is, apart from this issue, and this is for the working group, not for Mike specifically, who here believes that that these 3 documents are ready for working group last call? You can raise your hand for a change if you want to do that. All right. Who here believes that there is more, significant more work needed on the specs before they're done? All right. All right. So I think one way we could do this is to allow these guys a couple of weeks and then set a date for a working group last call, and you guys either come up with text and agree on consensus before that, or we last call it.
No, this is the comments on that.
Yes, Lucy?
If you do that, I would strongly suggest that you get a privacy considerations review.
You mean if we add additional text, or for this version?
If you think you're going to move these packages forward fairly quickly, I would strongly suggest
a privacy review?
Yes.
So should that be in last call or before last call?
Before last call.
All right. Anybody, can we get some volunteers to do that? I mean, I see some credible faces in the room, DKG and Wendy. You think you guys could sort of actually use your brains and sort of focus on this and just give us the scrutiny it so richly deserves? Please? Please?
Yeah, so I'm Martin Thompson. I haven't looked in the last little while, but once this happens, whatever this is, I certainly intend to have a good look at this. And I'm really worried about this from the privacy perspective. So
all right.
The more I think about it, oh, isn't that nice for, sort of said, oh, couldn't we just do some awesome cookie synchronization with this? That'd be great.
Martin, do you think can we peg you to do a privacy review right now?
As in before?
I mean, not today, but before we last call this, right? It would be. Doesn't have to be before dinner. It can be before lunch tomorrow. I mean, that'd be fine.
No pressure.
No, not at all.
I'm happy to have another look at it, but I don't know that there's anything. I don't know that there's anything that I'm going to be able to do in that sort of time frame, I'm afraid.
No, I mean, in all seriousness, we're talking about maybe a month before we go into working group last call here.
Yeah, well, in a month I can certainly do it.
Huh?
That's not a problem.
But I mean,
I've been behind on this working group for a little while now. But
on that time frame, I think a lot of implementers actually do want to sort of start to wrap this up. And if that means doing, like, focusing the working group a little bit and getting this done, I think that'd be great.
You, sir, are on my to-do list.
Does that sound reasonable, Wendy?
Yes, Wendy Seltzer, I'm also
Perfect.
willing to review.
Yeah,
Right.
I certainly don't want to be the only one, because I don't want that responsibility.
So Jeff, can you take the notes that we're volunteering and taking names? Yeah, excellent. And then we're looking at a time frame of doing a working group last call within a month. Within a month. So we should, get this done. I think we're off to Brian. Do you want to?
I have one more slide.
Oh, you have one more slide, man.
No, keep going. We've talked about that already. Keep going. I forgot that slide.
And we
We did
spent
that.
lots of time.
This was the only other one, pointing out that once we started inventorying the ways that OAuth is used, just in the OAuth context, there's a bunch of other uses of tokens over channels. For instance, for client authentication, that you would want to define the syntax of how you put the token binding information into the JOT or into the SAML token and sort of fill out the zoo.
Right.
Thank you.
Let's see if I can find Brian's stuff. I don't know, did we get slides from you?
Yeah, he sent it several times.
Yeah. See if I can find them. That's not there.
My spam filter
That's it?
deletes
No.
his email immediately, so.
Docu thing,
Oh, yeah? That thing you mean?
the one on the side, right?
Which is it? Is it that one? That one?
That one. That's why I put.
Cool, you put pictures in it. That's genius. That's genius. No, but
That would be cool, though.
all right.
All right. Take me back one so I can.
Oh, you want to say hello?
Yeah, I want to say hello. So that's a fun little thing to follow. So bear with me here as I recover from that conversation. I do like to put pictures in my presentations. This was from the last IETF here, and it helps Leif find them as he's looking through his doc. But this is up in Tiergarten Park nearby. They call it the pregnant oyster here, the locals. So I wanted to talk about a token binding method for OAuth 2 proof key for code exchange. Next slide, please. So I did the same presentation both for this group and for OAuth tomorrow. So I tried to give a little bit of background context here. This slide's meant to review token binding, so I don't think anyone needs that. I'll skip this one. I will review proof key for code exchange, what's commonly called PXE. It's defined in RFC 7636, called that proof key for code exchange by OAuth public clients. And the acronym has been cutely shortened to PXE. It's a mitigation of an authorization code interception attack for OAuth native clients. Generally, those are native clients running on a mobile device or sometimes a desktop device. There's nothing precluding its use on other types of OAuth clients, but specifically that's what it was geared towards. I didn't get a chance to say it in the previous session, but mention that there are a number of different OAuth clients, and I think maybe that was leading to some of the confusion in the conversation previously as well as the fact that OAuth specifically calls an entity a client, where I know a lot of times people, especially outside of the OAuth world, talk about client as the web browser. In OAuth parlance, client is an entity there. It's an active entity in the interactions that works with other things. And so in the general sort of authorization code flow, there's an authorization request that's spawned in a user's browser that interacts with the authorization endpoint at the authorization server. That's where the user authenticates, approves access, and at the end of that is redirected back to a URL that identifies the client, the redirection URI. And in that redirect, there's an authorization code that the client turns around and sends to the authorization server to exchange it for the actual tokens that it'll use. Typically, it's an access and a refresh token. So in PXE layers on a few things to this to prevent the case that another application on the same device is registered with a conflicting URI. So you send off this, the client sends off the request, the redirect comes back, and either with a local web server or a registered custom URI scheme, the application picks that up, and there's cases where a malicious application could intercept that redirect and register itself with the URI or listen on the same host, and then turn around and present the code and steal the tokens. And what PXE does is sort of bind together the initial request with that resolution request in order to make sure that some other entity, some other malicious app didn't pick it up. So what happens is that initial authorization request is sent, but included with it are a code challenge and a code challenge method. The user authenticates and approves in step 2 there. In step 3, the authorization response comes back with that code, and then the client takes the code, sends a request to the token endpoint to resolve it, and includes a code verifier that's tied back to that code challenge. And if all goes well, the token response and is sent back with the access and refresh tokens. So in the initial versions of PXE, there's 2 different ways this works. The code challenge can be just a long random string and with a challenge method of plain, and that basically means the same thing will be handed back when the verifier is sent. So in the plain method, you send the challenge as a long string, you send the exact same thing with the verifier, and the authorization server's job is to bind that long string into the code somehow and verify that it's the same one when it gets the request to resolve the code. There's also a SHA-256 transform method, which does basically the same thing, but the The challenge method is S256, I think. And the code challenge then is a SHA-256 transformation of some random string. And then when the code verifier is sent, it's the raw string that the hash was originally derived from. The authorization server, again, has bound those things to the access token. I mean, to the, excuse me, to the authorization code, but it reproduces the hash and compares the two. One, I think, important piece to realize here is that the authorization request and response and the interaction there occur through some browser on the user's device, in the case that it's a native application. And it could be any browser. It's typically, if we're following guidance, the system browser. And the interaction with the token endpoint occurs directly from the client itself. As would, not shown in here, but additional steps to actually use that access token would be directly from the client as well to some APIs or resource server. Next slide, please. So token binding for Pixie is using token binding to do a variation of Pixie. And at least as I've had it written up, the authorization request is the place where the code challenge is included. The code challenge in this case is a base64 URL encoding of the hash of the provided token binding ID that the client will use when calling the authorization server's token endpoint. So when it's going to make that call to resolve the code, that's the provided ID associated with that connection that it's going to include a hash of in the authorization request in the code challenge. The code challenge method here is just TB2, a short but semi-meaningful identifier for this transformation method. And then on the access token request, this is where it turns around and delivers the code in exchange for the tokens. The token binding header with the token binding message and provided token binding ID, assuming all that's negotiated, is sent. And the authorization server's job then is to compare that the token binding sent, the provided token binding sent on that connection matches up with the hash of that token binding ID sent on the original request. And in this case, the code verifier parameter is simply the static value provided. According to the Pixie RFC, it's a required parameter, and just to meet that, even though we don't need any actual data in it to meet that requirement, I just put a static identifier in there. Next slide. So why bother with this? And it's actually kind of a good question, I think. We were exploring token binding and its applicability to OAuth in general, and this is one of the cases that's been talked about over time, as well as the ones that Mike talked about. But this was one out there, and I wanted to write up just sort of a proposal of what it might be done. But it's not entirely clear to me that the token binding the code is materially better than doing one of the other Pixie methods that already exist. I may be overlooking something, but it doesn't seem to add much value beyond that. So it's more of just an open question and sort of some exploratory work at this point. Next slide. And so this is kind of more for the OAuth group, but definitely take thoughts here as well, is what are the next steps? And that's also a good question. I'm not sure what to do with it. I mean, one thing to do is say that it's really not that valuable and just get rid of it or sort of let it die on the ID wire. Or consider moving forward with it, possibly as an OAuth working group document, and maybe as part of consolidating as part of the document that Mike's working on. I know William asked me earlier why there's so many documents, and that's a common refrain in OAuth is why are there so many documents? And so I could potentially see one broad OAuth document that sort of covers the token binding applications or token binding profiles for OAuth that covers all these different use cases and consolidates into a single document. And in fact, I think that if we chose to move forward with this concept, that would be my preferred way of dealing with it, is to merge it in with a larger token binding OAuth document, or just let it sit, marinate for a while before making any decisions on it, or some other solution. I mean, I mentioned I'm not sure it's materially better, and that may be well because I've overlooked some aspect of how it works or what it provides, or another way of doing it. And in general, reading it and feedback is appreciated. Dirk.
This is Dirk. To the why bother? So one way of thinking about this is as a sort of a public private key version of Pixie, where Pixie is sort of a symmetric key version where I just show you the secret, and that's how I prove possession of secret. Whereas here I do a public key signature. So what this protects against that Pixie doesn't protect against is man-in-the-middle attacks where someone is sitting in the network and potentially intercepting your challenge and challenge verifier. So yes, we should bother.
So, as one of the, stepping in as one of the co-authors, yeah, so it does dramatically improve the security of the client authentication from something that, if it's a public client, it doesn't have any separate client credentials. So this is actually a big step up in security. The other thing is that it perhaps gets around some implementation issues where people may not choose particularly secure Pixie challenges and verifiers. That if you have a lower level of the operating system that is actually generating keys, people may get it right more often. So there's a couple of good reasons. I have been playing with another idea, which is token-bound client IDs, which may actually. So imagine if you could token bind if the client did an out-of-band dynamic client registration step with a software statement and got back yet another assertion that was token bound, you could actually get more benefit from that and perhaps simplify some provisioning issues. So if we want, this is one of the proposals. It may be down the road we look at maybe there's a better way of doing this and we don't actually need this extra step. It's certainly better than the S256, but there may be other things that we come up with that give us more benefits for less work.
Well, if the client's in the cloud, if the client is a server, then maybe doing something like channel binding the client ID or client secret or something like that I could see. But if the client is a native app on a billion phones, maybe we should talk.
Yeah, we can talk about it later. We have this in the OAuth work group later. So we're going to cut the line off after William.
Question for you, John, is isn't something like that necessary to get to LOA high number? Like something like the existing Pixie doesn't quite cut it for that, right?
Yeah, so for a higher LOA, having a better assurance of what the client is, and that may fit into the app attestation stuff that we're also talking about. So there may be a more holistic thing that we can do, but.
So in terms of the dynamic registration piece, that's probably possible, but in a lot of ways, Pixie emerged exactly to avoid the need to do dynamic registration and has caught on really well to do that. In terms of, help me understand, if there is in fact a man in the middle in this scenario, he could intercept the initial authorization request and insert his own token binding hash for the code challenge. And I'm not sure I follow then how.
So it'd be man in the middle on the communication between the client and the token endpoint, where they could, if it isn't a token bound connection which is being verified, then in principle you could have a man in the middle that would just intercept the code verifier.
Okay.
So you get increased security around not having man in the middle attacks on the token endpoint by passing the verifier through a separate channel, which isn't perfect but is better.
We're actually soon out of time here, so keep it short.
So both, one thing I wanted to understand is whether this prevents against attacks like in Android and iOS, you can register for.
We've cut the line, so you might as well sit down.
In Android, you can register for HTTP request URLs with intent filters, for instance. So does this solve the problems where other apps can intercept your OAuth requests to browser or something?
That's what Pixie does. Yes. Next.
And the Pixie that exists now will do that.
Carl Maida, I understand Pixie is just distinguish two apps residing on the same device by this verifier token, but I think this token binding thing binds to the connection between the device to the server. So maybe if we have an HTTP2 cost scenario like that, So the maybe different app can reside in the same TLS connection in this case, if this comes into the picture. So if we want to accommodate this kind of chorus thing, want to share something, then this scenario is good. But if we want to separate them, maybe not.
Good point. That needs to go in the security considerations around scoping of stuff. Next.
I just wanted to point out that the original Pixie was for native apps, but I think this Pixie for token binding is actually important even for web servers, because it is just referring to that back channel. And the second quick comment is, and this is kind of mostly inspired by Dirk's review actually, but I think we need to look at token binding for OAuth as like one whole, that the goal shouldn't be, let's like separately token bind each individual thing. So my comment about the drafts is not sort of a flippant, like we have too many documents, because but actually more around how we approach this problem. And I think the Google team approach has been, the goal is that we want to token bind the OAuth tokens end to end. And how do we achieve that goal? What are all the things that are needed to achieve that? And I think that is a good way of actually looking at the problem, rather than, oh, we have like, this thing, let's token bind that and do everything separately and hope that when you add it all up, it actually equals what we wanted.
I don't disagree.
All right, folks, we're out of time. See you all in Seoul, or maybe not if we work, let's not see each other in Seoul. No, there's only. It's the Stone Ages. Well,
Yeah, I don't.
Who has blue sheet, by the way? Thank you.
They're having a working group meeting. I don't know why. It's email. Where's the email?